Right now, far past anything you can see, a galaxy is slipping out of reach forever. It is not flying away through space. Space itself is stretching between us and it, faster than any ship or signal could cross. Once it passes a certain line, nothing we ever do can touch it again. The universe is quietly closing itself off, one galaxy at a time. And if the cosmos is as crowded with life as the numbers promise, then someone out there has watched this happening for billions of years. They would be racing to spread before their reach ran out. So the night should be loud, full of signals, full of engines, full of light from other minds. Instead, it is silent. A physicist named Enrico Fermi felt that silence one afternoon and asked the question that still has no answer. Where is everybody? And the deeper you look into time, the worse that silence gets. Picture a lunch table in the high desert. A few physicists, trays of food, the kind of loose talk that fills a midday break. They had been joking about a recent run of flying saucer sightings, the sort of thing that ends up in a cartoon. The subject moved on. They ate. And then, with no warning, one of them looked up and asked a question that had nothing to do with the food in front of him. Where is everybody? The man was Enrico Fermi, one of the sharpest minds of his century. The kind of physicist who could estimate almost anything in his head from almost nothing. He was not asking about the room. He was asking about the sky. In a few silent seconds, he had run the numbers the way he ran every number, and the answer had bothered him enough to say out loud. His logic was simple, and that is what makes it hard to shake. Our galaxy is old. It has been turning for billions of years before our sun even formed. There are countless stars in it, many far older than ours, many with planets. If life is the kind of thing that happens when conditions allow, then somewhere out there, again and again, it should have started long before us. Some of it should have grown clever. Some of the clever ones should have begun to spread. Even crawling between stars, at a fraction of the speed of light, a single curious species could touch every corner of the galaxy in a few million years. Against the age of the galaxy, a few million years is nothing. A blink. So the galaxy has had more than enough time to fill up many times over. By every reasonable reading of the math, someone should already be here, or should have left a mark we could not miss. A signal. A ruin. A machine drifting through our solar system. Something. And there is nothing. That is the whole of it. Not a mystery built from strange data, but a mystery built from absence. The strangeness is not what we see. The strangeness is what we keep failing to see, in a universe that should be loud with company. Fermi felt that gap at lunch, and named it in 4 words, and the 4 words have outlived him by generations. People often soften the question into a curiosity, a fun thing to wonder about on a clear night. It is not curious. It is wrong, in the way a missing footprint in fresh snow is wrong. The setup promises a crowd. The result delivers a held breath. For a long time, the smartest response was patience. We had barely looked. Of course, the sky seemed empty. We had not aimed the right instruments at the right places for long enough. Give it time, point the dishes, scan the stars, and the company will show itself. That was the hope, and it was a reasonable one. But the silence has held. It has held through better tools and longer searches and decades of careful listening. And while we listened, we learned something else about the universe. Something Fermi did not know and could not have guessed at that table. The thing he was puzzling over is not sitting still. It is changing. It is closing. And when you fold that one new fact into his old question, the question stops being a riddle for after dinner. It turns into something colder. Start with the count, because the count is where the trouble begins. Look up on a dark night, far from any city, and you might see a few thousand stars. That is almost nothing. That is a thin scatter of the closest, brightest neighbors in one small arm of one ordinary galaxy. The real number is hidden behind them. Our galaxy, the Milky Way, holds somewhere between 100 billion and 400 billion stars. Hold that for a second. Not 100 billion as a figure of speech, but as a literal count of separate suns, each one a furnace, many of them older and steadier than ours. If you tried to greet them one at a time, one per second, you would still be counting after 10,000 years. Now, widen the frame. Our galaxy is one galaxy. The universe we can see holds up to 2 trillion of them. 2 trillion galaxies, and each one is its own swarm of billions of stars. Multiply it out and the human mind quietly gives up. The stars in the visible universe outnumber every grain of sand on every beach and in every desert on Earth, and not by a little. Then came the part that turned this from a wonder into a problem. We used to think planets might be rare, that our solar system was a lucky arrangement. We do not think that anymore. When we learned to detect worlds around other stars, we found them almost everywhere we looked. Big ones, small ones, frozen ones, scorched ones. The current reading is that planets are not the exception. They are the rule. Most stars have them. Many have several. And among all those worlds, a real fraction sit at the right distance from their star for liquid water. Not too hot, not too cold. The same mild conditions that let life take hold here. There are billions of those gentle worlds in our galaxy alone. Billions. In one galaxy, among trillions of galaxies. This is the engine under Fermi's unease. He did not need exotic assumptions. He only needed the universe to be large and old, and stocked with ordinary planets around ordinary stars. All 3 turned out to be true, and more true than anyone expected. You can feel the pressure building from the numbers alone. If life needs a warm, rocky world, and a steady sun, and a few billion years of quiet, the universe has offered that deal an unthinkable number of times. For the sky to be empty, almost every single one of those deals has to have come up empty. Every warm world, every patient sun, every long stretch of time, all of it, barren except here. That is a strange thing to ask of a universe this big. The bigger the universe gets, the harder the silence is to explain, because a bigger universe means more rolls of the dice, and more rolls means the unlikely should have happened somewhere, many times. So the count does not comfort. The count accuses. It tells you the sky should be crowded, and then leaves you alone with the fact that it is not. And once you accept the scale, the next question is obvious. If the odds are this good, can we put a real number on how many neighbors we should have? Someone tried. A radio astronomer named Frank Drake decided to do something Fermi never did. He decided to write the silence down as math. He gathered the people thinking about this question into one small meeting, and he put a single equation on the board to organize the conversation. It was not meant to give a final answer. It was meant to break a huge, fuzzy question into a chain of smaller ones you could actually argue about. The idea was clean. To estimate how many talking civilizations might be out there right now, you multiply a string of fractions together. Start with how many stars form. Cut that down to how many have planets. Cut that to how many planets could hold life. Then how many actually grow life? Then how many grow intelligent life? Then how many build something that sends a signal we could catch? And finally, how long such a civilization lasts before it falls quiet. Each step trims the number. You start with an ocean of stars, and you filter it, stage by stage, down to a handful of possible voices. That was the genius of it. It turned a vague feeling into a series of guesses you could improve as you learned more. And here is what happened as we learned more. The early steps, the ones we have measured, all came back generous. Stars form constantly. Planets are everywhere. Worlds in the gentle zone are common. The front of the equation, the part we can now check against real data, points toward plenty. So if you sit down with reasonable numbers, the kind that do not assume anything strange, the equation often hands you a galaxy that should be humming with civilizations. Not one, not 10. Sometimes thousands, scattered across the Milky Way. Some of them broadcasting, some of them ancient. The math, fed with honest values, predicts company. For a while, this felt like hope wearing the clothes of science. You could look up and believe the loneliness was temporary, a matter of finding the right channel. The equation made optimism feel rigorous. It said the others were out there and we simply had not tuned in yet. But an equation is only as solid as its weakest term, and the back half of Drake's chain is built on terms we cannot measure. We have exactly one example of life, one example of intelligence, one example of a species that builds radios. From a single data point, you cannot honestly know whether the odds of that step are 1 in 10 or 1 in a trillion. The equation is a frame with a hole in the middle, and into that hole each person pours their own hope or their own dread. That is the quiet trap inside the optimism. The numbers we can check say the galaxy should be full. The numbers we cannot check are the only things standing between that prediction and the empty sky we actually see. Somewhere in those unknown terms hides the reason for the silence, and the equation cannot tell us which one it is. Drake gave us a way to ask the question precisely. He could not make the universe answer. So we stopped writing on chalkboards and started building dishes, and we pointed them at the stars, and we waited to hear something. Anything. For decades now, in patient shifts, people have been listening to the sky. The work is not dramatic from the outside. Giant dishes turn slowly toward chosen stars. Computers sift the incoming static for anything that does not look natural, anything with the fingerprint of intent. A narrow tone at a single frequency, a pattern that repeats with purpose, a whisper of order in the noise. The searchers know what an artificial signal should look like, and they have spent lifetimes hunting for one. The galaxy is wide open to this kind of looking. Radio waves cross light years without much trouble. If a civilization anywhere nearby were leaking signals the way we do, or worse, beaming them on purpose, our instruments stood a real chance of catching the edge of it. We have scanned thousands of stars. We have swept across huge stretches of the sky. We have listened across many frequencies, including the ones a thoughtful sender would likely choose. Once, the listening jumped. A telescope picked up a strong, narrow burst that hit every mark of something engineered. It was loud. It came from the direction of deep space, not from any local source anyone could pin down. One astronomer was so struck by it that he wrote a single word beside the printout. Wow. The signal lasted a little over a minute and then it was gone, and it never came back. No matter how long anyone watched that patch of sky. That is the shape of the whole search. Now and then a flicker that makes the heart jump. Then nothing. Every candidate chased down turns out to be a natural source, or a piece of our own technology bouncing back, or a fluke that will not repeat. Nothing has ever stood up as a real voice from out there. Nothing has ever answered. It would be easy to wave this off. The galaxy is enormous. Our search, even after all this time, has only sampled a sliver of it. We have listened to a tiny patch of stars for a tiny window of time, on the frequencies we happen to choose. Maybe the others are there and we simply have not pointed the dish their way, or tuned to their channel, or caught them in the brief moment they were transmitting. That is true. The search is far from complete, but notice the direction the evidence keeps pointing. Every honest reason for the silence is a reason about us. We have not looked long enough. We have not looked in the right place. We have not looked the right way. Each one puts the failure on the searcher, never on the possibility that there is nothing to find. That is a comfortable habit, and it may be the wrong one. Because the longer the listening goes on without a single confirmed voice, the more weight the empty result has to carry. Silence is cheap to dismiss once, twice, 100 times. It gets harder to dismiss when it stretches across generations of better and better instruments, all returning the same nothing. At some point, a steady, repeated absence stops being a gap in our search and starts being a finding in its own right. Not proof that we are alone, but data. Real data, paid for with decades of careful work. And when you treat the silence as data instead of as an excuse, the whole question shifts under your feet. Think about what an empty result actually is. In science, when you run a careful test and get nothing, the nothing is not wasted. It tells you something. If you search a building for an intruder and find no one, room after room, the empty rooms are not failures. They are evidence. They narrow down where the intruder can be. Enough empty rooms, and you start to doubt there was ever an intruder at all. The long silence from the sky works the same way. Each quiet star, each dead channel, each chase signal that turns out to be a microwave oven or a passing satellite is one more empty room. None of them alone proves much, but they add up. And the pile has grown very large. This reframing matters because of how people talk about the search. They call it a failure. They say we have not found anything, as if the instruments let us down. That is backward. The instruments worked. They returned a clean result. The result is just one we did not want. The universe was asked a question, and so far it has given a consistent answer, and the answer is quiet. Set that quiet against everything the Count promised. A galaxy of hundreds of billions of stars, planets almost everywhere, billions of gentle worlds with the right warmth and the right chemistry, and billions of years to work with. An equation that, fed with reasonable numbers, hands back a sky that should be busy with neighbors. All of that on one side. On the other side, the steady, growing, well-measured silence. The two do not fit. That is the heart of the paradox, and it is sharper than a casual mystery. A paradox is what you get when two solid facts cannot both be true, yet both seem to be. The universe is built to make life. The universe shows no other life. One of those statements has to bend, and we do not know which. Maybe life is far rarer than the warm world suggest, and the back half of Drake's equation hides a near impossible step. Maybe civilizations rise often and die young, so the galaxy is full of ruins and short of voices. Maybe they are out there and silent on purpose, hiding, or simply uninterested in shouting into the dark. Each of these explanations saves the facts at a cost, and each cost is unsettling in its own way. But all of those guesses share a hidden assumption. They all picture a universe that sits still while we figure it out. A fixed stage with a fixed cast, where the only question is how many actors are standing in the dark. Solve the riddle of who is out there, and the silence resolves. The sky stays the same while we work. That assumption is false. The stage is not fixed. The universe Fermi puzzled over. The one Drake tried to count. The one the dishes have been listening to is not holding still. It is moving. It has been moving the whole time, in a way no one at that lunch table imagined. And the direction it is moving turns the silence from a puzzle into a warning. Because the universe is not just large and old and quiet. The universe is leaving. For most of human history, the universe seemed like a fixed room. The stars held their places. Whatever the cosmos was, it simply was. The same yesterday and tomorrow. Then we learned that the room is growing. The galaxies are not sitting in space at fixed distances. They are drifting apart, all of them, in every direction, because the space between them is stretching. Not the galaxies flying through space, but space itself expanding and carrying them along, like dots drawn on a balloon as it inflates. Every dot sees every other dot moving away. There is no center. The whole thing is swelling. That alone was a shock when we found it. But people assumed the expansion would slow down. It had to, surely. All that matter, all that gravity pulling inward, should act like a brake. Throw a ball up and gravity drags it back. The expanding universe should do the same, coasting outward, slowing, maybe one day falling back together. So a group of astronomers set out to measure exactly how fast the cosmos was hitting the brakes. They looked at exploding stars far across the universe, a special kind that always burns with nearly the same brightness. Because the true brightness is known, the apparent dimness tells you the distance, and the stretch in their light tells you how fast the universe was expanding when that light set out. By gathering enough of these distant explosions, the teams could chart the expansion across cosmic time and see the break at work. There was no break. The measurements came back pointing the other way, and the result was so strange that the teams checked it again and again, half expecting an error. The expansion is not slowing. It is speeding up. The galaxies are flying apart faster now than they were in the past, and they will fly apart faster still in the future. Something is pushing the universe open, and pushing harder over time. That something has a placeholder name. We call it dark energy, which is really just a label for our ignorance. We do not know what it is. We only know what it does, and what it does is win. It makes up roughly 7 out of every 10 parts of everything that exists. More than all the matter and all the stars and all the dark matter combined. It is the dominant fact of the cosmos, and we cannot say what it is made of. Here is the part that matters for our story. Gravity pulls things together, and it gets weaker as things spread out. Dark energy pushes things apart, and as far as we can tell, it does not weaken at all. As the universe grows, gravity loses ground, and dark energy keeps its strength. So the push is fated to beat the pull. The expansion is not a phase. It is the future. It accelerates, and the acceleration compounds, and nothing we know of can stop it. A still universe and an accelerating one are two completely different worlds, for Fermi's question. In a still universe, the others are simply somewhere out there, waiting to be found. In an accelerating one, the distances themselves are growing while you search. The room you are scanning is getting bigger every second, and the far walls are pulling away. That changes everything about what it means to be alone. It means some of the others, if they exist, are not just far. They are getting farther, beyond any hope of reaching right now as you read this. Take a galaxy far out near the edge of what we can see, and watch what the expansion does to it. The space between us and that galaxy is stretching. Add up all that stretching across all that distance, and the galaxy's apparent speed away from us climbs. The farther a thing sits, the more stretching space lies between, and the faster it recedes. Push far enough out and you reach galaxies whose recession adds up to faster than light. That sounds like it breaks a rule. Nothing can move through space faster than light. But these galaxies are not moving through space that fast. The space between us is expanding that fast, and expansion is not bound by that limit. The galaxy sits quietly in its own patch, going nowhere special, while the gulf between us widens faster than any beam of light could ever close it. Sit with what that means. If you sent a signal towards such a galaxy right now, traveling at the absolute speed limit of the universe, it would never arrive. The space ahead of it would open faster than the signal could cross. The light would run forever and fall farther behind. That galaxy is not far away in the way a distant city is far away. It is cut off, walled off by the growing space itself. No ship, no message, no influence of any kind can ever reach it again, no matter how long you wait or how fast you go. There is a line in the sky where this becomes true. Closer than the line, a thing is still reachable in principle if you set out now and never stop. Past the line, it is gone for good. Astronomers call this boundary the cosmic horizon, and it is not like the horizon at sea, where you can sail closer and reveal more. This horizon does the opposite. As the expansion accelerates, the line draws inward. The circle of things we can ever touch is shrinking, and the universe is feeding galaxies across that line one after another, steadily, silently. Every galaxy out near the edge is on a conveyor belt running away from us. Right now, while nothing dramatic seems to be happening, a galaxy somewhere is crossing the line for the last time, passing out of our reach forever. Then another. Then another. The cosmos is quietly subtracting itself, removing destinations from the map of everything we could ever go. This is not a far future event. It is happening continuously, in the present tense, by the thousands. The reachable universe is leaking away at this very moment, and the leak only speeds up. For most purposes, none of this seems to matter. The galaxies leaving are absurdly far off. We are not going anywhere near them. We can barely leave our own solar system. Why would a line billions of light years away mean anything to us, or to anyone? It means something the moment you stop thinking about us and start thinking about a civilization that wants to grow. Not stay home, grow. Spread out across the cosmos and claim it. For a species like that, this shrinking line is not a curiosity. It is a clock, a countdown to how much of the universe they can ever own. And that clock, it turns out, can be measured. Someone sat down and figured out exactly how much is slipping away. You can put a number on the loss, and the number is brutal. Look at the universe we can see. All those galaxies stretching out in every direction, up to 2 trillion of them. It is natural to assume that this is the universe we could, in principle, travel to. Hard, sure. Slow, sure. But reachable, given enough time and patience and impossibly good engineering. That assumption feels safe. It is wrong. Run the calculation of which galaxies a signal or a ship leaving today could ever actually arrive at. Given the accelerating expansion, and the answer collapses. Of all the galaxies we can see, only a small fraction are still reachable at all. The rest, the overwhelming majority, are already past the line. We can see their old light, the light they sent long ago, but we can never reach the galaxies themselves. They have already left the realm of anything we could touch. The fraction we can still reach is something like 3 in every 100. 3%. Out of 2 trillion galaxies, the ones a traveler setting out at the speed of light today could ever arrive at number a sliver of the whole. Everything else is a picture, a postcard from a place that no longer takes visitors. We are looking at a sky mostly made of the unreachable, mistaking the view for the territory. And that sliver is not holding steady. It is shrinking. As the expansion accelerates, galaxies that are reachable today will not be reachable tomorrow, in cosmic terms. The window for ever touching them is open now and closing. Wait too long, and the door swings shut, one galaxy at a time, faster and faster as the ages pass. Estimates of the rate are staggering in their own quiet way. By some reckonings, the universe carries thousands upon thousands of stars across the line of no return every passing year, lost from the set of places anything originating here could ever reach. Whole worlds, whole future destinations, removed from the map, while nothing visibly changes in the night sky. The subtraction is invisible and relentless. This is the deadline no one set and no one can move. There was no committee, no decision, no enemy. The structure of the universe itself imposes it. Dark energy, whatever it is, has drawn a line under the cosmic ledger and is steadily closing the account. Any civilization that wants to claim a large share of the universe has a finite, ticking window in which to do it, and the window narrows every moment they delay. For us, this lands as a strange kind of grief for places we never knew. But for the central question, the silence, it lands as something sharper. Because now imagine a civilization that understood all of this. A species that looked up, measured the expansion, and realized exactly what we just realized. That the universe is closing. That every age of hesitation costs them galaxies they can never get back. That to claim a share of everything, they would have to move, and move now, and move fast. Such a civilization would not sit quietly. It could not afford to. The clock would drive it outward, hard. In a race it could feel ticking. And a species racing across the cosmos to beat a closing door is not the kind of thing you can hide. It is the kind of thing that should be impossible to miss. Imagine you are that civilization, and you have done the math. You know the universe is expanding faster every age. You know that every passing era strips reachable galaxies from your future, by the thousands, forever. You know that the cosmos you can still claim is at its largest right now, and will only ever get smaller. If you want a share of everything, if you want to gather resources and worlds and time before they drift past your horizon, there is only one rational move. Go. Now. As far and as fast as you can. Staying home is a slow surrender. Every year you wait at your home star. Galaxies you could have reached cross the line and vanish from the set of places you can ever go. Patience is not safe. Patience is loss. The expansion punishes hesitation, and it punishes it on a cosmic scale, erasing more of your possible future the longer you stand still. So, a civilization that grasps its situation faces enormous pressure to expand outward as quickly as physics allows. Not out of greed exactly, and not out of fear of us, out of arithmetic. The universe hands them a closing window and a simple choice. Spread now and keep some of the cosmos, or wait and watch it slip away. Any clear-eyed species that wants a future of any size has to choose the first. An expansion across the stars does not require magic. It does not require beating the speed of light or bending the rules. It only requires patience and machines. Send out craft that travel at a modest fraction of light speed. Have them arrive at a new system, gather raw material, build copies of themselves, and send those copies onward. Each settled system becomes a new launch point. The frontier does not crawl outward. It explodes outward because every new world doubles the effort, the way a single spark becomes a wildfire. Work out the timing, and it is dizzying. A wave like that, even at a tenth of light speed, could cross an entire galaxy in a few million years. It could spread across the spaces between galaxies, claiming everything still inside the closing horizon in a span that is long by human reckoning, but a flicker against the age of the universe. A civilization with a head start of even a few 100 million years would have had time, many times over, to reach across vast regions of the cosmos. So the race against space has a clear winner's strategy, and it is loud. Expand early, expand fast, fill everything you can reach before the door shuts. This is what a civilization driven by the real structure of the universe would do. Not whisper, not hide. Surge outward in a visible, growing, unstoppable wave. This is where the closing universe and Fermi's silence finally collide. The expansion does not just remove galaxies, it creates a powerful reason for anyone out there to be sprinting across the sky, building, settling, transforming worlds, leaving a mark that grows with every passing age. The cosmos should be full of these surges, or at least bear the scars of past ones. Some thinkers gave these expanding waves a name. They called the civilizations behind them the grabby ones, and the grabby ones by their very nature are the opposite of quiet. A small group of researchers took this idea and pushed it to its sharp edge. They asked a focused question. What if some civilizations expand hard and fast, grabbing everything they can reach? And what would a universe full of such grabbers look like? They called these expanders grabby civilizations. The defining trait is simple. Once they get going, they spread outward at a large fraction of light speed, and they change whatever they reach. They do not tiptoe. They settle systems, restructure them, harvest stars, and keep pushing the frontier. A grabby civilization is not a faint radio signal from one planet. It is a growing sphere of altered space, swelling across the sky, getting larger every year. The key feature is that you cannot overlook one. A faint civilization on a single world might broadcast weekly, or not at all, and slip past our searches. That is easy to imagine. But a grabby civilization is a different kind of thing entirely. It is reworking whole regions of the cosmos. As its sphere grows, it would dim or alter the light of countless stars, leaving a clear, expanding signature stamped across the heavens. From far away, you would see a spreading patch where the universe looks engineered rather than natural. And because they expand so fast, there is almost no in-between stage where they are hard to notice. They go from a single world to a vast visible empire in what is, on cosmic timescales, the blink of an eye. You would not catch a grabby civilization in some quiet middle phase. Either they have not reached your part of the sky yet, and you see nothing, or they have, and they are everywhere around you, impossible to ignore. There is no soft, faint version to miss. This sharpens Fermi's question into something much harder. The old hope was that the others are simply too quiet for us to hear, broadcasting weekly from distant worlds. The grabby idea takes that comfort away. It says that if expanding civilizations exist at all, they are not subtle. They are the loudest, most obvious things the universe could possibly contain. Spheres of transformed space, billions of light years across, growing visibly across the ages. So the relevant question is no longer whether we can hear a faint whisper from one planet. It is whether the sky shows any sign of these enormous, spreading, unmistakable empires, and the model makes a hard prediction about that. If grabbers are common, the universe should be carved into their territories. Vast regions reworked, light altered across enormous stretches. We should look up and see, or soon find, the edges of someone else's expanding domain bearing down on our region. When we look, we see none of it. No spreading spheres, no engineered regions swallowing the natural sky, no frontier of altered stars marching toward us. The grandest, most visible thing a civilization could ever do, and there is no trace of it anywhere we have looked. which forces a strange and specific conclusion about where we sit in all of this. Run the logic forward and it traps you. If grabby civilizations are common in the universe, then they are out there expanding right now, each one a sphere of claimed space, growing across the cosmos. Spheres grow. They fill the available room. Over enough time, they would meet. And between them, they would carve up everything reachable. The way oil spreading on water eventually covers the surface. Now ask where that leaves us. If the grabbers were common and old, their spheres would already be enormous, and the odds that our little world sits in one of the rare, untouched gaps between them would be tiny. Far more likely, by sheer volume, we would have been swallowed long ago. We would have been born inside someone's territory, under a sky already reworked, on a world already claimed or passed over. The empty patches shrink as the spheres grow, so a randomly placed observer should almost always find themselves inside a sphere, not outside all of them. Yet here we are, in a sky that looks wild and natural and untouched. No engineered region presses against our borders. No expanding frontier darkens our horizon. The local universe shows every sign of being unclaimed. And that fact, the ordinary natural sky over our heads, becomes evidence. It tells us that grabby civilizations are not thick on the ground around us. If they were, we would already be living inside one. This is the squeeze. The same model that makes expanding civilizations so visible also makes their absence meaningful. We cannot comfort ourselves that they are simply hiding, because grabbers by definition cannot hide. We cannot say they're too far to see, because their spheres grow precisely to bridge those distances. The only clean way to explain a natural, unclaimed sky is that the loud expanders are rare, or young, or somehow have not arisen near us in the time available. So the silence deepens. It is no longer just that we hear no faint signals. It is that we see no empires either, and empires are the one thing that should have been impossible to overlook. Both the whisper and the shout are missing. The galaxy is quiet on every channel, from the smallest radio leak to the largest reworking of the stars. And the grabby model does something else, something that turns the unease inward. It does not only predict where the others should be. By balancing how often grabbers appear against how fast they fill the universe, it makes a prediction about when an unbothered observer, someone like us, sitting in a still, natural sky, should expect to find themselves alive. It pins down our place in time. The answer it gives is not reassuring. It says that a civilization born into a sky still free of grabbers, a civilization with room to wonder why it is alone, should appear early. Surprisingly early. Long before the universe reaches its busiest, most crowded era of life. The very fact that we can ask the question in a quiet sky suggests we are near the front of the line. And that turns out to match a separate, independent strangeness about our moment. One that has nothing to do with aliens at all. By the universe's own clock, we have shown up far sooner than we had any right to. Step back from the silence for a moment and look at the calendar of the cosmos itself. The universe is not young. It has been expanding and cooling for nearly 14 billion years. From inside a single human life, that is an unimaginable stretch of time. It is easy to assume we have arrived late, at a mature universe, near the end of the interesting part. Most of the story already told, and us walking in for the final act. The opposite is true. By the measure of how long the universe will remain capable of hosting life, we've arrived almost at the very beginning. The cosmic afternoon has barely started. We are not the latecomers. We are among the first guests, standing in an empty hall while it is still being set up. Here is why. Stars are still forming, and they will keep forming for a very long time. More importantly, the most common stars in the universe are small, dim, red ones, far smaller than our sun. These little stars are misers. They burn their fuel so slowly that they last not for billions of years, like our sun, but for trillions. A small red star can shine steadily for 10 trillion years, or longer. That is 1,000 times the entire current age of the universe, packed into the lifespan of a single ordinary star. And those long-lived stars are exactly the kind that could shelter life for almost unlimited spans. A world circling a steady red star would have not billions, but trillions of years of warmth to work with. Trillions of years for life to start, to develop, to grow clever. The window for life around such stars is not closing. It is barely open. The vast majority of all the habitable time the universe will ever offer lies in the future, not the past. So weigh the two ends against each other. Behind us, nearly 14 billion years. Ahead of us, potentially trillions upon trillions of years, in which stars still shine and worlds stay warm. If you laid out the full span of cosmic habitability as a single day, life-friendly conditions stretching far into the deep future, then our present moment would not fall at noon or in the evening. It would fall in the first faint minutes after dawn. This is genuinely odd, and it does not depend on any alien at all. If life can arise around the common long-lived stars, and those stars will dominate the universe for ages to come, then most of the observers who will ever exist should appear much later than us, basking in the long, crowded afternoon. We should expect to be born into that busy era, alongside countless others, because that is when the universe is most full of life. Instead, we find ourselves here, at the cold early edge, in a sparse and quiet cosmos, with the great age of life still ahead and unspent. Out of all the moments we could have opened our eyes, we open them at one of the earliest possible ones. And that raises a question that has nothing to do with radio signals and everything to do with us. Why now? Why so soon? Let the scale of the future settle in, because it is hard to hold. We talk about billions of years as if that is the limit of deep time. It is not. The universe is just getting started. Ahead lie not billions, but trillions of years in which stars still burn and planets still turn in gentle orbits. The era we live in, the bright young cosmos of large hot stars and active galaxies, is a brief opening flourish. The long body of cosmic time is something else entirely, slower and dimmer, and almost endless by comparison. For roughly the next trillion years, new stars will keep igniting from the gas that drifts between the stars. Galaxies will go on making suns, though more slowly as the ages pass. And the small red stars already burning will keep burning the entire time, outlasting generation after generation of larger stars, holding their worlds in steady warmth across spans that make our sun's lifetime look like a single afternoon. If life is something the universe does when given a warm world and time, then the deep future is where almost all of it should happen. Picture the universe 10 trillion years from now. The bright young galaxies are long faded, but countless small red stars still glow, each one a quiet hearth, many with worlds that have had trillions of years of calm to brew whatever life can brew. By every measure of opportunity, that distant era should be the high season of the living cosmos, far richer in life than our own thin morning. This is the long afternoon, and it is almost entirely unspent. The overwhelming majority of all habitable time the universe will ever contain lies ahead of us, not behind. If you imagine every conscious being who will ever exist, scattered across all of cosmic history, the great mass of them should belong to that future, not to our sparse early hour. We're the rare few who showed up before the room filled. And yet that staggering future comes with a shadow over it, the one we have been tracing. While the long afternoon stretches forward, the universe is also pulling itself apart, fast at every age. So the deep future is a strange place. Each red star and its worlds will sit warm and stable for trillions of years, but the wider cosmos around them will be emptying out, galaxies fleeing past one another's horizons, the reachable universe shrinking toward nothing, long life on each island, and ever wider dark water between the islands. That combination is the trap closing in slow motion. There is plenty of time ahead for life. There is less and less room ahead for life to reach anything beyond its own small patch. Anyone born into that long afternoon will have trillions of peaceful years and almost no chance of ever crossing to a neighbor, because the neighbors will have long since drifted out of reach. So the unspent future is not a simple promise of company to come. It is a vast, warm stretch of time that the expansion is quietly walling off into separate cells. And it throws our own moment into even sharper relief. We are early, in a cosmos that is busy locking its doors, which forces the question that has been gathering under all of this into a single, hard point. Put the pieces on the table together and look at them at once. The universe should be full of life, by every measure we can check. It will remain capable of hosting life for trillions of years, with the great majority of that time still ahead. Most conscious beings who ever exist should therefore be born into that crowded future, not into our sparse early morning. And any civilization that does arise has overwhelming reason to expand outward, fast and visibly, before the accelerating cosmos walls it off. Every one of those statements points the same way. The sky should be busy, now or soon, or in our past. There should be company or signals, or the spreading mark of someone who came before us and grabbed what they could. And we sit in silence, at one of the earliest possible moments, in a natural untouched sky, asking where everyone is. The strangeness is not any single one of these facts. It is how they stack. We are early when we should be late. We are alone when we should be surrounded. We exist in a quiet natural cosmos, when the model says a typical observer should find the sky already claimed or already crowded. Each fact alone is a curiosity. Together they form a shape, and the shape is wrong in a way that is hard to look away from. There is a clean question hiding in all of it, and it is sharper than Fermi's. He asked where everybody is. The deeper question is why we exist at this particular instant, so close to the cosmic dawn, in a universe that has trillions of years and untold worlds of life still ahead of it. Out of all the moments we could have been born, why this oddly early one, in the thin quiet before the great crowd arrives? There are only a few ways to answer that, and none of them is comfortable. Maybe we really are among the first, the genuine pioneers, arriving before almost anyone else in a universe that will fill up long after we are gone. Maybe life is so rare that the warm worlds and the long ages do not matter, because the spark almost never catches. Or maybe something stops civilizations before they can spread, some wall in the path that every species hits, which would mean the future crowd we keep imagining never actually shows up. Each of those answers reaches forward and touches us. If we are the pioneers, then the silence is just the silence of being early, and the burden of the cosmos may be ours to carry. If life is that rare, then we are a fluke so unlikely it borders on the impossible. And if there is a wall in the path, then the real question becomes whether we have already passed it, or whether it is still ahead of us, waiting. That last possibility is the one that turns the whole inquiry cold. Because it suggests the silence is not a puzzle about them at all. It is a warning about us, a barrier somewhere in the road from a dead world to a galaxy-spanning civilization. A barrier so severe that almost nothing makes it through. And the only question that matters is which side of it we are standing on. There is a way to read all of this that lets you sleep. It hangs on a single idea, and the idea is almost gentle. Somewhere on the long road from a lifeless world to a civilization that fills the sky, there is a step so hard that almost nothing clears it. A wall. A place where nearly every path ends. Find that wall, and the silence makes sense at last. The road has many stages. A dead world has to brew the first living thing. That first life has to survive and multiply. Simple cells have to become complex ones. Complex life has to grow into many forms, then into something that thinks, then into something that builds, then into something that reaches past its own star. Each stage is a gate. And if even one of those gates is nearly impossible to pass, then the galaxy would be littered with worlds that started the journey and stalled, and almost none would make it to the end. The hopeful version places the wall behind us. It says the hardest step is one we have already taken, without knowing how rare it was. Maybe the birth of life itself is the near impossible event, a piece of luck so freakish it happened only here. Maybe it was the jump from simple cells to complex ones, a leap that on Earth took billions of years and may have happened exactly once. Whatever it was in this reading, we are past it. The deadly gate is in our history, cleared, survived. Notice what that would mean. It would mean the silence is not a threat. It is just the long quiet of being one of the very few worlds that got lucky early. The others are missing because they never formed, or never grew complex, or never learned to think. We slip through the eye of a needle that almost nothing else fits through. And now we stand on the far side, rare and alone, but safe. The danger is behind us. The road ahead, while empty, is open. This is the comforting filter, and there is real reason to take it seriously. Life took hold on Earth quite early, almost as soon as the planet cooled enough to allow it, which hints that getting started might not be the bottleneck. But the next step, the rise of complex cells from simple ones, sat frozen for an enormous stretch of time. For roughly half the history of life on this planet, nothing more than simple cells existed. Then, once, the leap happened, and everything we call complex life descends from that single event. A step that takes billions of years and seems to have occurred only once has the fingerprint of something staggeringly improbable. If that was the wall, then we are the strange survivors of a near miss, and the empty sky is the expected view from the rare world that made it. No one is out there because the gate let almost no one through, and we are on the lucky side of it. You can build a whole piece around that thought. The worst is over. We are the exception that proves how harsh the rule is. It is a clean answer, and it would be a relief if we could be sure of it. But the filter has a darker face, and the trouble is that the same silence fits both readings exactly. The quiet sky cannot tell you whether the wall is behind you or in front of you. It only tells you the wall is there. And if it is not behind us, then there is only one other place it can be. Turn the idea over, and the comfort drains out of it. The filter is a wall that civilizations do not pass. We have been hoping it sits in our past, a hurdle already cleared, but nothing forces it to be there. The wall could just as easily lie ahead of us, on a part of the road we have not reached yet. And if it does, then everything that makes us feel advanced becomes a countdown. Here is the logic, and it is hard to escape. If the early steps were not that rare, if life starts readily and complex life follows, and intelligence is a natural outcome, then the galaxy should be full of species that got as far as we have. Worlds with cities, with science, with rockets, with radios, and yet none of them are spreading across the sky. None of them became the loud, grabby expanders the universe seems to invite. So, something stops them. Something reliably ends civilizations, or prevents them from ever crossing into the stars after they reach roughly our stage. That something would be in our future. A gate we have not yet walked through, that almost nothing walks through. And the more ordinary our early history looks, the more likely the wall is ahead rather than behind. Every time we learn that life starts easily, or that planets are common, or that the early steps were not miracles, we are quietly moving the wall forward, toward us, into the road we have yet to travel. What could such a wall be? It would have to be something that catches nearly every civilization that reaches the technological stage, with almost no exceptions, because the silence is almost perfect. A danger that a species creates for itself as it grows powerful, perhaps. The same knowledge that lets you build starships lets you build the means to end yourself, and maybe that ending comes on world after world before the starships ever launch. Or maybe the wall is subtler, some trap of growth or complexity that we cannot yet see, that closes on advanced life again and again across the cosmos. We cannot name it, and that is the worst part. We can only see its effect, written in the silence. If the wall is ahead, then the quiet sky is not the peace of being rare. It is the warning left by everyone who came before and hit the wall and fell silent. The galaxy will be quiet not because life is scarce, but because the road runs out over and over, just past the point where we now stand. And this is where the closing universe presses in again, because it changes which version we should fear. Remember that the early steps on Earth do not look especially rare. Life appeared fast. That speed is a hint that the Great Filter may not be behind us after all. If the hard step is not in our past, then by simple elimination it lies in our future, on the stretch of road we are about to walk. So the two readings of the filter are not equal. One lets us rest. One tells us the most dangerous moment of our entire existence may be the one we are living in, or the one just ahead. The silence cannot say which is true, but it can do something else. It can keep shrinking the very stage on which the answer would play out, narrowing our options while we stand here arguing about them. While we debate where the wall lies, the map keeps getting smaller. Go back to the reachable universe, the set of all places anything from here could ever touch. We found that it is far smaller than the visible universe, only a few galaxies in every 100 that we can see. But a snapshot hides the real story. The reachable universe is not a fixed territory, it is a melting one. Every moment, the accelerating expansion carries more of it out of reach, and the part that remains shrinks. Think of it as an island whose shoreline is always pulling inward. Stand at the center, and the land looks vast, but the edges are eroding, steadily, and the rate of erosion grows. Galaxies near the boundary cross over and are gone, removed from the set of everything you could ever visit. Then, the new boundary erodes too. The island never grows. It only ever loses ground, faster as time goes on. Put numbers to the loss and it stops feeling abstract. By careful estimates, the universe varies on the order of many tens of thousands of stars across the line of no return every year, lifting them out of our reach forever, not destroying them, simply moving them past the point where any signal or ship from here could ever arrive. Whole worlds, whole suns, quietly subtracted from the realm of the possible, while the night sky looks utterly unchanged. And the unchanged sky is the cruel trick. From where we stand, nothing seems to be vanishing. The stars hold their patterns. The galaxies still glow in our telescopes because their old light is still arriving, light they sent ages ago when they were closer and still within reach. We see the postcard long after the place itself has left. So the shrinking is invisible to the eye. You would never know, looking up, that the door is closing. You have to do the math to feel the loss. For us today, this seems to cost nothing. We cannot reach those galaxies anyway. We can barely leave our own neighborhood. The shrinking map is a tragedy with no victim, a loss of options we were never going to use. So it is tempting to shrug it off. The far galaxies were never ours to begin with. But the map matters enormously for the question we have been chasing, because it sets the size of the stage on which any company could ever exist for us. The others, if there are any, do not have to be merely out there in the visible universe. To matter to us, to ever meet us or signal us or be met, they have to be inside the reachable patch, the shrinking island. And that island is small and getting smaller. So the search for company is not a search across the whole vast sky we can see. It is a search across a far tinier region, the part we could actually share a future with. And that region is being whittled down in real time. Every year, the volume in which we could ever encounter anyone gets a little smaller. The odds of company inside it a little thinner. We are not just looking for neighbors in a quiet cosmos. We are looking for them in a cosmos that is steadily shrinking the very space where a neighbor could be found. And inside that small remaining island, there is a particular kind of absence that should bother us most of all. Forget the distant galaxies for a moment, and look closer to home. The grandest way to cross space does not need a crew, or speed near light, or any breakthrough we cannot already imagine. It needs only a machine that can copy itself. Send out a single craft that can land on a world, gather raw material, and build a working copy of itself from what it finds. Then have it launch the copies onward to do the same. 1 becomes 2, 2 become 4. The number that fans out doubles with each step, and doubling is the most powerful force in arithmetic. A wave of self-copying probes like that does not creep. It floods. Even moving at a small fraction of light speed, with long pauses at each world to build the next generation, such a wave could sweep across the entire galaxy in a few million years. Against the age of the galaxy, that is the snap of a finger. A single civilization, anywhere in our galaxy's long history, that chose to send out even one self-copying explorer, could have filled every system with their machines many times over before our sun was even born. So, consider what that means for our own backyard. Our galaxy is old. It has hosted countless stars for billions of years longer than Earth has existed. If even one civilization arose in all that time and all that space, and built even one self-copying probe, then their machines should already be here. In our solar system, drifting among the planets, sitting quietly on a moon, woven into the asteroid belt. The math says our neighborhood should hold the fingerprints of someone else's expansion, left long ago. And when we look, we find nothing. No ancient probe, no machine that is not ours, no structure, no relay, no derelict craft from another world parked in our system. We have studied the planets up close, mapped the moons, tracked the small bodies, and every object we find is natural or is something we put there ourselves. The backyard that should be crowded with the leavings of a billion years of possible visitors is, as far as we can tell, completely untouched. This is a harder silence than the radio silence, in a way, because it does not depend on catching anyone in the act of broadcasting. A probe does not have to be transmitting. It only has to exist, to have been left behind. It is a physical thing that should still be sitting where it was placed, waiting to be found. The radio search can fail because we tune to the wrong channel at the wrong time. The probe argument has no such escape. The machines should simply be here, and they are not. So the absence is not about timing or frequency. It is about presence. The cheapest, most patient, most foolproof way to make your mark on the galaxy is to send out copying machines and let time and doubling do the rest. It requires almost nothing beyond a decision and a head start, and the galaxy has handed out billions of years of head starts to anyone who wanted one. The result should be a galaxy salted with probes, including ours. Instead, our corner is clean. Either no one ever arose to send the machines, or everyone who could chose not to, or something stopped them all. Each of those is its own kind of unsettling, and every one of them adds weight to a silence that was already getting hard to hold. Stack the absences and feel how the weight changes. For a long time, each piece of the silence had an easy answer, and the easy answers were reasonable. No radio signals. Well, we have barely searched, and they might broadcast on channels we have not tried. No probes in our system. Well, maybe interstellar travel is harder than it looks, or maybe no one bothered. No grabby empires in the sky. Well, maybe they are simply too far, beyond what we can see. One by one, the explanations held. But notice that each easy answer assumes a still universe, a fixed stage where the only question is whether someone is on it. Fold in the closing cosmos, and the easy answers start to fail, one after another, like fuses blowing in a row. Take the idea that the others are simply too far to have reached us yet. In a still universe, that works. Distance is just distance, and maybe they have not crossed it. But the universe is not still, and the expansion creates a hard reason for anyone to cross that distance fast, before it closes. The closing door does not let civilizations dawdle out of reach. It drives them to spread early and quickly, precisely so they would have arrived by now. The acceleration turns far away into a problem they would have raced to solve, not an excuse for their absence. Take the idea that we have not searched long enough. The closing horizon answers that too, in a brutal way. The window for company is not infinite and patient, it is finite and shrinking. The longer we wait to find anyone, the fewer places remain where anyone could be. Time is not on the side of the search. Every year the reachable region grows a little smaller, and the silence grows a little more complete. So waiting does not improve our odds, it worsens them. Take the comfort that maybe they are out there but quiet, keeping to themselves. The grabby logic already strained that, because expanders cannot hide. The closing universe finishes it off. A civilization that wanted any future at all could not afford to stay quiet and small, because staying small means watching the cosmos wall itself off around you while you do nothing. The expansion punishes restraint. It rewards the loud and the fast. So a universe full of permanently shy civilizations is not just unlikely. It runs against the very pressure the cosmos applies to anyone who wants to last. This is what the closing universe does to the paradox. It removes the soft places to stand. Each gentle explanation that once let us shrug off the silence relied underneath on a calm and patient cosmos that would wait for us to figure it out. The real cosmos is neither calm nor patient. It is accelerating, closing, subtracting destinations every year, and pressing every possible civilization to expand hard or lose everything. Under that pressure, the silence should have broken long ago. Someone should have raced out and filled the sky while there was still sky to fill. And they did not. The quiet holds, not against a still backdrop where it is easy to excuse, but against a backdrop that should have made quiet impossible. That is why the silence gets heavier the closer you look at time. It is no longer the gentle hush of a universe waiting to be explored. It is the wrong, ringing silence of a place where everything was driving toward noise, and none came, which forces the bleakest reading of where we actually sit. Say the hard thing plainly. Inside the patch of universe we could ever reach, there may be no one but us, not no one in the whole cosmos. The whole cosmos is unthinkably large, far bigger than the part we can see, and somewhere out in that vastness there may well be others. But others do us no good if they sit beyond the closing horizon. In galaxies we can never touch, and that can never touch us. For every purpose that matters, for meeting, for signaling, for sharing a future of any kind, the only company that counts is company inside the reachable island. And that island may be empty of everyone but us. This is a colder claim than ordinary loneliness. Ordinary loneliness still imagines that the others are out there, just out of sight, and that one day the gap might close. The closing universe forbids that hope for most of the sky. The gap is not closing. It is widening, faster every age. The galaxies we cannot reach are not getting nearer. They are fleeing, and the set of places we could ever share anything with is shrinking down toward our own small neighborhood. So picture the situation honestly. We sit in a causal patch, a bubble of everything we could ever affect or be affected by, and that bubble is finite and slowly contracting. Inside it, the radio is silent. Inside it, the backyard holds no probes. Inside it, the sky shows no spreading empires. Every search we have run, every place we have looked within the region that matters, has come back empty. The bubble that defines our possible company looks, so far, like it contains exactly one civilization. Ours. And here the early timing returns to haunt us because it fits this picture too well. We arrive near the cosmic dawn, in a sparse, quiet sky, before the universe filled. If we are among the first, then of course our reachable patch is empty. The crowd has not arrived yet. We're the early ones, alone, not because life is forbidden, but because we beat almost everyone to the stage. That reading would be almost flattering, except for what the expansion does to it. We are early, and the door is already closing. We arrived before the crowd, and the crowd may now never reach us because the space between us and any future neighbor is opening faster than anyone could cross it. So the early arrival and the closing horizon combine into a trap with no exit. If we had come late, the universe would already be too spread out to cross, and we would be islanded among the embers. We came early instead, which should have been our luck. Our chance to reach out while the cosmos was still small and crossable. But the reaching has to actually happen, and it has to happen soon, because the window that was open at our early hour is closing even as we stand in it. Early is only an advantage if you move. Stand still, and early becomes just another word for alone. That is the possibility we have to face. Not that the universe is empty, but that our share of it is. That we are sealed by the geometry of an accelerating cosmos into a region where we may be the only ones who ever wake up. And if that is true, then the silence is not waiting to be solved. It is the simple sound of a closing room with one occupant. The only question left is how much of the room we can still claim before it shuts. And that question has a deadline that is already running. The deadline is the part people skip because it does not feel like one. A deadline usually announces itself. A clock on the wall, a date circled, a voice counting down. This one does none of that. It is silent, written into the expansion itself, and it ticks whether or not anyone is watching. Every age that passes, the universe removes destinations from the set of places anything here could ever reach. The clock does not stop, and it cannot be argued with, because it is not a rule someone made. It is the shape of space coming apart. We touched the size of the lost before, but sit with the direction of it. The reachable universe is at its largest right now, this moment, and it will never be this large again. Tomorrow it is smaller. 1,000,000 years from now, smaller still, and the shrinking is faster then than it is today, because the expansion accelerates. So whoever wants to claim a share of the cosmos faces the worst kind of countdown, one that speeds up as it runs. The longer you wait, the less there is to take, and the rate of loss climbs the whole time. This reframes what a civilization racing outward would actually be racing against. Not another civilization, not us, the expansion itself. Every galaxy they fail to reach in time is gone forever, lifted past their horizon, no matter how advanced they later become. There is no catching up. There is no later launch that recovers a lost galaxy. Once it crosses the line, it is permanently out, and the only galaxies you ever get are the ones you reach before they cross. So, the strategy that wins is brutally simple. Move as early as you possibly can, and spread as fast as you possibly can, because every moment of delay is paid in worlds you can never get back. And this is exactly the behavior the silence rules out. If the cosmos drives every ambitious civilization to expand early and fast, then the sky should already bear the marks of that sprint. Spreading spheres, altered stars, a frontier bearing down from somewhere. The closing window does not make expansion rare. It makes expansion urgent, the most rational thing a civilization could possibly do. Which means the absence of any visible expansion is not a neutral fact. It is the absence of the one thing the universe most strongly encourages. For us, the window has a personal edge, and it is easy to miss because it feels so remote. We are early, in a still crossable cosmos, which is the best possible position from which to claim a share of everything. We hold, right now, the largest reachable universe anyone here will ever hold. That is not a permanent gift. It is the opening of a window that has already begun to close. If a civilization from here ever intends to spread among the galaxies, the time to begin is now, in cosmic terms, because the cost of waiting is measured in galaxies lost per year, and the price only rises. We will almost certainly not do it. We can barely cross our own solar system. The point is not that we are about to launch. The point is that even the option, the bare theoretical chance of ever claiming a wide share of the cosmos, is expiring on a clock we cannot reset. The grandest future a species could dream of has a closing date, and we are living before it, watching the window narrow without lifting a finger. To understand just how narrow even the open window is, you have to look at what claiming the cosmos would actually take. Lay out the scale of the task, because the scale is its own kind of horror. Suppose a civilization decided to do it, to reach out and claim as much of the reachable universe as physics allows, before the rest slips away. What would that actually require? Not in spirit, but in raw, grinding effort across space and time. The answer stretches the mind past where it comfortably goes. Start inside a single galaxy. To settle one galaxy means sending machines or travelers to hundreds of billions of stars, each one light years from the next, each crossing taking decades or centuries, even at a good fraction of light speed. The self-copying strategy makes it possible, since each settled world builds the next wave, but possible is not the same as small. It means an unbroken chain of arrivals and constructions and launches, repeated across 100 billion stars, sustained without failure across millions of years. One galaxy alone is an undertaking longer than the entire history of our species, many times over. Now, lift your eyes past the single galaxy, because claiming the cosmos means crossing the gulfs between galaxies, and those gulfs are a different order of empty. The space between stars is vast, but the space between galaxies is vaster by far. Dark stretches where a traveling machine would drift for millions of years with nothing to refuel on, nothing to land on, nothing to build from, until it reached the far shore. To spread from galaxy to galaxy is to leap across oceans of pure emptiness, again and again, on journeys that dwarf the crossing of any single galaxy. And all of it is a race against the closing horizon. The galaxies you're trying to reach are receding while you travel. The farther ones recede faster. So even a perfect expanding wave, launched as early as possible and moving at nearly light speed, can only ever catch the galaxies that have not yet crossed the line. Beyond a certain distance, you simply cannot get there, ever, no matter how flawless your machines, because the space ahead opens faster than you can close it. The reachable cosmos is not just hard to claim. It is the small fraction left after the expansion has already stolen the rest. Put it together and the picture is staggering. To claim even the reachable share, a civilization would have to flood hundreds of millions of galaxies, each holding hundreds of billions of stars, leaping the dark seas between them, sustaining the effort across billions of years, all while the expansion steadily snatches the outer targets away before the wave arrives. It is the largest project the universe permits, carried out against a deadline the universe itself imposes, and it has to begin almost at the dawn of a civilization's history to capture much of anything at all. This is the scale of what a grabby civilization signs up for. And here is the turn. That staggering, almost unimaginable project is precisely what the math says someone should already be doing, somewhere, if expanding civilizations are common. The very enormity of it is what would make it visible, an expanding stain of claimed galaxies spreading across the cosmos. So, the absence of that stain is not the absence of something modest. It is the absence of the single grandest process the universe could host. The one thing that should have been visible from billions of light years away. Nobody, anywhere we can see, is doing the one thing the cosmos most rewards. And the strangeness of that only deepens when you imagine standing in the far future and looking back. Travel forward in your mind, far past our early morning, and stand at the edge of deep time. Then ask what an observer there could even see. Pick a moment 100 billion years from now. By human reckoning, that is almost beyond meaning, yet on the cosmic clock, it is still early in the long afternoon of the small red stars. Suppose a civilization arises then, on a warm world circling one of those patient suns. And suppose they are curious, and they build telescopes, and they look up to map the universe the way we do. What greets their gaze? Far less than greets ours. By that time, the accelerating expansion will have carried every other galaxy beyond their horizon. The galaxies that we can see today, the 2 trillion points of light scattered across our sky, will all have receded past the line. Their light stretched and dimmed into nothing, gone from any instrument. The deep future observer would not see a sky full of galaxies. They would see their own galaxy, and beyond it, darkness, an empty black surrounding a single island of stars. Their own galaxy, by then, will have merged with its nearest companions into one large island, bound together by gravity, immune to the expansion because gravity holds it close. That island will still glow, full of stars, full of worlds, perfectly real and alive, but it will sit alone in a void that shows nothing else. To the astronomers of that age, the universe will appear to be one galaxy floating in an endless empty dark, with no sign that anything else ever existed. Sit with how complete that blindness would be. They would not see the expansion, because there would be no distant galaxies left to show it. They would not see the faint afterglow of the cosmic beginning, the ancient light that tells us how everything started, because the expansion will have stretched that light away to nothing as well. The very evidence we use to understand the universe, the receding galaxies and the leftover glow of the dawn, will have been erased by the same process that erased everyone's reach. The deep future hides its own past. So those astronomers, looking out with perfect instruments and sharp minds, would reach a reasonable, careful, and completely wrong conclusion. They would decide that the universe is a single galaxy, static, eternal, alone. No expansion, no beginning, no 2 trillion other islands of light. Everything we know about the shape and history of the cosmos would be invisible to them, not because they failed, but because the truth had physically left the observable sky. They would do good science and arrive at a false universe, because the real one had closed itself off beyond their seeing. This is the part that should make you cold, and it is not about aliens at all. It is about knowledge and how the window for it closes. We can see the true shape of the cosmos only because we are early, while the distant galaxies still hang in view and the dawn light still arrives. That view is temporary. It is a privilege of our early hour, and it is fading. The deep future is not just a place where reaching is impossible. It is a place where even knowing becomes impossible, where the universe deletes the proof of what it is. And that deletion has already begun. The erasing is not a distant event. It is underway right now, slowly, and it will not reverse. Every galaxy that crosses the horizon takes a piece of the evidence with it. Right now, we can see those 2 trillion galaxies and measure how they recede. And from that, we learn the universe is expanding and accelerating. That measurement is only possible because the galaxies are still in view. As the expansion carries them out, one by one, the data that revealed the expansion disappears along with them. The universe is, in a slow and literal way, removing the clues to its own nature. The ancient glow left over from the cosmic beginning is fading by the same logic. That faint light fills the whole sky and tells us in detail how the universe started and how old it is. But the expansion stretches that light, lengthening its waves, dimming it age by age. Given enough time, it will be stretched so far that no instrument could ever detect it. The single clearest fingerprint of the beginning will be smoothed out of existence, not hidden behind something, but genuinely gone, stretched into nothing by the growing space. So the cosmos is covering its tracks. The 2 great pieces of evidence that let us reconstruct the whole story, the receding galaxies and the glow of the dawn, are both on their way out, carried off or stretched away by the same acceleration. There will come a time when neither can be found by anyone, no matter how clever. The truth about the universe will still be true. It will simply be unrecoverable, with every trace of it pushed past the reach of observation. This means our moment is not just early. It is a rare lit window in the history of knowledge itself. We happen to live in the brief span when the universe still displays its own origin and its own expansion openly. for anyone with the right instruments to read. That display is not permanent. It is a fading exhibit, open now, closing slowly, and it will not reopen. The beings of the deep future, however brilliant, will inherit a cosmos that has hidden its own history from them, and they will have no way to know what was taken. There is something almost deliberate seeming about it, though nothing is deciding anything. The same force that walls off every civilization from every other, the same force that shrinks the reachable map and drives the silence, is also the force that erases the record of the universe's birth and growth. One process does all of it. The acceleration isolates, and it forgets. It cuts the cosmos into lonely islands and then, patiently, removes the evidence that the islands were ever part of anything larger. And we are watching it happen at the only moment when it can still be watched. We caught the universe with its history still showing, barely, in the thin early light, before the great forgetting sets in. That is an astonishing piece of timing, and it is the same timing that placed us alone in a quiet sky. We are early enough to see the truth and early enough to be alone with it. The two facts are the same fact, wearing different faces. Both come from arriving near the dawn, before the universe finished closing itself off, which leads finally to the place all of this has been pointing. The last island, and what it is like to be the only light in it. Go to the end of the long process, and look at what remains. Trillions of years from now, after the bright young galaxies have faded, and the small red stars have lived out most of their endless lives, the universe will have sorted itself into separate islands. Each island is a clump of galaxies that gravity bound together early, fused into one, holding itself close against the expansion. Between the islands lies pure void, growing wider every age, uncrossable, dark. Each island sees nothing of any other. Each is a universe unto itself, a single glowing patch in an endless black. Our island is already forming. Our galaxy and its nearest large companions are bound by gravity, fated to merge into one great island of stars that the expansion can never tear apart. Everything else, the 2 trillion galaxies beyond, will drift away past the horizon and vanish from view. So the far future of our region is a single merged galaxy, alone, surrounded by a darkness that shows nothing. One lit patch, and around it, nothing at all that anyone there could ever see or reach. Picture standing on a world in that island, in that deep future. The local sky still has stars. Your own galaxy still glows around you, full of suns, perhaps full of worlds. Up close, everything seems fine, even rich. But turn your gaze outward, past the edge of your island, and there is only black. No other galaxies, no distant lights, no sign that anything exists beyond your single patch. The universe to you is one island floating in an infinite empty sea, and you have no way to know it was ever otherwise. That is the final isolation the expansion builds. Not a cold, dead cosmos, but a living patch sealed inside a forgetting one. There may be other islands out there, other glowing patches with their own stars, and maybe their own minds, but you can never know it. Never reach them, never even suspect them, because the void between has grown beyond any crossing, and the light between has stretched to nothing. Each island is alone, and worse, each island cannot even tell that it is alone among others. It simply seems to be everything there is. And here is the thread that ties it back to us. Sitting in our quiet early sky, the deep future island is the silence made permanent. We feel the silence now as a puzzle, a question we might still answer. Because we are early and the cosmos is still open, and the others, if any, might still be found. The future island feels nothing as a puzzle, because by then the question is unaskable. The isolation is total and the evidence is gone. Our silence is the soft beginning of that. Theirs is the finished form. So we live at the one moment when the closing has started but not finished. The galaxies are leaving but still visible. The reach is shrinking but not yet gone. The silence is here, but the sky is still open enough that we can wonder why. We are early enough to see the whole structure, the company that should exist, the reach that is closing, the islands forming, the forgetting setting in, and to feel the full weight of it while the window is still open. That privilege, the privilege of being early enough to understand, brings us all the way back to a man at a lunch table, asking a simple question into a quiet room. Return to the high desert, and the trays of food, and the loose midday talk. Return to Enrico Fermi looking up and asking where everybody is. When he asked it, the question was a sharp curiosity, a puzzle about a galaxy that seemed emptier than it should be. He did not know the universe was accelerating. He did not know the reachable cosmos was shrinking, or that we sit near the cosmic dawn, or that the sky erases its own history, or that the far future is a scatter of lonely islands, forgetting they were ever joined. He felt the silence with none of that underneath it, and even then it bothered him enough to say out loud, "Now, put everything we have stacked up back onto that simple question, and feel how its weight changes." Whereas everybody is no longer just about a quiet galaxy. It is about a universe that should be full, that will stay habitable for trillions of years, that drives every ambitious civilization to expand early and loud, and that still, against all of that pressure, shows us nothing. The question Fermi asked in a few idle seconds turns out to sit on top of the deepest features of the cosmos, and the more we learn, the heavier it gets rather than lighter. Because each thing we have discovered since that lunch was supposed to help, and each one made it worse. We learned planets are everywhere, which should mean more company, and the silence held. We learned worlds in the gentle zone are common, which should mean more company, and the silence held. We learned the universe will host life for ages to come, which should mean a crowded future. And yet we find ourselves alone at the start of it. Every fact that should have filled the sky left it emptier by contrast. Until the silence is not a gap in our knowledge, but a result we cannot explain away. And the closing universe is the part Fermi never had. It takes his patient puzzle and removes the patience. In a still cosmos, you can always say the others are out there and we will find them eventually. In an accelerating one, eventually runs out. The window for company is open now and shutting, the reachable region shrinking every year. The easy explanations failing one by one against a backdrop that should have produced noise and produced quiet instead. The same question, asked against a closing universe, stops being a thing to wonder about and becomes a thing to reckon with. So the 4 words have grown heavier than the man who said them could have known. Whereas everybody is now braided together with why are we so early? And why is the sky so natural? And why does the cosmos drive expansion yet show none? And why are we awake at the one moment when all of this can still be seen? They are not separate questions. They are one question, seen from different sides, and it presses harder the longer you hold it. Fermi felt a small version of that pressure at a lunch table and named it in 4 words. We have spent this whole time learning how large the thing behind those 4 words really is. And the strangest part, the part that turns the whole inquiry back on the one holding it, is not out there in the silent sky at all. It is in the timing. It is in the fact that you are here to consider any of this now, in the narrow lit window before the universe closes and forgets. So here is where it lands. You exist at the edge of time, not the end of it, the front of it. In the thin early light before the universe fills or empties, whichever it is going to do. Almost no one who could ever live has lived yet. And almost everything that will ever leave reach has not yet left. The door is open. It is the most open it will ever be. And you happen to wake up while it was still open enough to notice it closing. That is the real reveal under Fermi's silence. The quiet sky is not telling you only that the others are missing. It is telling you when you are early. So early that the cosmos still shows you its whole structure, the receding galaxies, the glow of the beginning, the company that should be there and is not. A being born later would see less, reach less, know less, and finally see nothing at all, and call the dark the whole of things. You got the rare seat, the one with the view, in the brief age when the view exists, and the silence, held against all of that, leaves you with a fact that is hard to set down. Either we are alone in our reach, the only light that ever wakes inside our closing patch, or the wall that silenced everyone else still waits somewhere on the road ahead. The empty sky does not say which. It only says that the time to matter, if there was ever going to be one, is the early time. The open time. The time you're standing in. Most of cosmic history will be lived by beings who can see almost nothing and reach almost nothing. Sealed in islands that forget they were ever joined. You are not one of them. You arrive before the closing, in the one window where the whole thing is still visible and still, barely, still open. That is not comfort. It is not a promise that we will do anything with it. It is just the plain shape of where you are in time, and it is stranger than any place you could have been. The galaxy that was slipping out of reach when this began has slipped a little further while you listened. Another one crossed the line. The window narrowed by a fraction no eye could catch. None of it waited for us to understand it. It never does. You are early. The sky is quiet. And the edges now.